a chapel window consisting of 4 equal rectangles and a semicircle. So we have 1, 2, 3, 4
Yes.
rectangles. The length of the metal that is being used for the frame is 36 meters. So this thing here, guys, all in all, they are saying which you have 36 meters to make this thing here. When how you structure it, it doesn't matter. They are just telling you which all in all, when what you have 36 meters to work with. So what did you have? You have 4 rectangles, 4 rectangular shapes. And then you also have 1 semicircle. And then if we go to this question here, let's check. The most important thing is for us not to come back with 0. That's where we are going to start. Let's not come back with 0. So what is the first thing that we can see here? They say which we should prove that the area for the frame is given by area, which is going to be blah, 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 as Khotso will say. And then, now, this one can be a little bit challenging for us. So I will encourage you to say, if for us to do number 2, we don't need any part of this thing, because sometimes it happens that you still have to differentiate. Yeah, and so you can check that. But here they are saying, determine the length of the base PQ. So we are looking for base PQ for maximum area. So we want the area to be maximum. But we're already given the area. Since we're given the area, we can skip to this 5 marks. It's fine. Yeah, let's leave this 6 marks for now. And then let's start, because these are also examination skills. On an exam, you say, okay, but let's start with 10.2. 10.2. If you go with 10.2, then it says area in terms of x. So we differentiate the area in terms of x. It gives us 24 minus 8 x. And then it's going to be minus 2
minus
pi.
5 over 3 x squared. Minus 5 over 3 x squared.
Oh, okay. All over x. Was I correct?
So we think I get who pi over 6. I get who here as a decimal. They're wrong. I want in decimals.
The pi.
Yeah, pi over 6.
Yeah, but remember the reason why we usually don't do anything with these things is because we need to round off the final answer. So if you start playing with decimals as early as possible here, you might have a problem. So we're going to have 0. We're just going to be equal to 24. And then it looks as if you have minus 8x. And then this one, it's minus 1 all over 3. 1 over 3 pi x.
Yes.
And then this is strange because these two are like terms.
Yes.
But it's not so visible.
Yeah.
So we'll have to try to do it so that it becomes visible for anyone. So you have minus 8 minus 1/3. Maybe that's why they put it there, because they suspected what we might not see. And then we have pi. Where's pi?
Times 10 of x.
So it's shift.
Yes.
It's pi.
Yes.
Okay. So this is an answer.
It's a minus.
So we should leave it like that.
We should leave it like this. There's nothing that we can do. But I can also transpose it to this other side and go geometrical. So it says we have minus 9, comma 9,047. I know you don't round up here. You round off the final answer. 19. Okay. Yeah, because I'm going to round off to 2 decimal places, I can take it to 5 decimal places that side. And then this is going to be 24. This is x. You divide by minus. This one, when you took it to that other side, it was positive. Should be positive. 9,04719. Okay, we said we are dividing.
Yes, divided.
This is positive also. Okay, let's do this maybe to avoid confusion, because I can see I've made multiple mistakes. So we say we add this one and this one. This one is still 24. This one and this one is the one that gives us minus 9, what is that? 0, 4. 4719. Okay, yeah. Chairman was saying something. I had missed him. Chairman, yeah?
Mister, what if now more? Here differentiate the payela guy did 0.
You differentiated what? This thing?
He differentiate pi be 0.
Why do you want pi to be 0? Because pi is a number, but it's like you have 2,5 x squared.
Ngere, I was taught or what differentiate something that is different to X. Differentiate it as zero.
No, this one here, we said if you're differentiating, let's say I had pi, let's say I'm differentiating in terms of X. I have area which is going to be equaling to pi, plus X, let's say 2 pi X squared. This one doesn't have an X on it. We regard it as a constant because we're differentiating in terms of X. But this one here, if you look at this one here, because it has an X, so we're going to differentiate everything that is, because it has an X, we're going to differentiate in terms of this X. And then this thing here is no longer a constant because it has an X. So it becomes the value just before X.
Okay.
Yes. Okay, so we got this, and then we take this one to this other side.
Yes.
And then we have 9,
0.04
719, which is X, which is going to be what to be 24. You divide both sides. 0, or 9,04.
719.
It's 719. Even this side you divide by 9,04 719. Therefore, X is going to be, let's check X. How would I do it? Because I know how to play with the calculator. I'll say I already have 24, but it won't work because that one was negative. So it's 24 divided by the answer. But I want the positive answer. So X is going to be
2,65.
2,65.
Yes.
Like this.
Yes.
Okay. So we have 2,65. So we take the positive one.
Yes.
2,65. Okay, sharp. Now, what did they want, Bona? Basically, they wanted the length from here to here. So we get X to be 2,5, 2,65. Then it means which PQ.
I want to times it by 2.
Is going to be equaling to 2 times, because it's going to be X and X. And then it's 2 times 2,65. And then if we go there,
Sorry.
we can say multiply by 2. And it gives us 5,3.
1. 5,31.
5,31. Okay. Now, at least we would have gotten the 5 marks because they're going to give us a mark for differentiation, making the derivative to be 0. Simplification, this one, and then getting the final answer. All in all, then we're going to get your 5 marks. Let's go back and collect the 6 marks then. Do you have an appetite for it? Also thinks he has the appetite. Sure.
Oh, so ladies and gentlemen, let's analyze the diagram again. So if you look at this diagram, this is a rectangle made up of 4 smaller rectangles again, and then a semicircle again on the above what again. So now if I analyze this diagram, I find the perimeter of this thing is going to be given by
Maybe let's start what we are looking for. Actually, they say we should prove that the area is. So I will say to Elena, let's start with the area and say, how would you get the area? Agree, the area all in all, it's like you are going to get the area of the small thing. Remember this area, and then we are going to get the area of this one. And we're going to get the area of this one, the area of this one. So what is the area of the small rectangle? It's H multiplied by X.
It's HX.
So basically we have 4
HX
HX
plus pi.
You have this one, which is a semicircle.
Yes.
Pi r squared divided by 2.
Yeah, so for an area of a circle, you will say which you have pi r squared
over 2.
But this one, since it's a half a circle, you say divided by 2.
Yes.
So plus.
But we know the radius. The radius is x. So
the radius,
pi
yeah,
x squared.
Yeah, from here to here. This is going to be x, so it's the radius. So we'll tell them which we have pi x squared all over 2. Okay, let's come here. So we have pi x squared all over what? All over 2. Now I want us to notice something here. They will give us a mark for this because we're able to get the area. But the only challenge that we're having is that we are dealing with h, and then we're also dealing with what? With n.
Okay, with x. Yes.
So if Elena, let's say they said r squared, Will they give us a mark? I think they will also give us a mark. I'm not sure, but I think because we're dealing, you shouldn't have many variables. Like that's the goal.
Yes.
Try to make it to have as minimal variables as you can. Okay, that's the problem, very much.
Yes.
I think this we would have gotten one mark.
Yes.
For knowing the area of a rectangle and knowing the area of a
Or
semicircle.
semicircle.
Sharp.
Yes.
So how should we proceed? Yeah.
Oh, now if we go back to the statement, they say that
Yeah.
they say that the length of a metal that is being used for the frame is 36 meters again. Now they say that the metal that is used to create this frame, the length of it is 36 meters again. So what they're trying to tell us, mostly if they're talking about length, I think about perimeter again. So perimeter of ours is going to be equal to 36 meters again. Now, what is a perimeter, ladies and gentlemen? Perimeter, by my own understanding, is the sum of all sides of the shape that are given. One here, so the perimeter of this one is going to be equal to but this we're having a semicircle, remember, a semicircle, I can remember. Now, if I'm going to be adding this, if I'm going to be having a sum of all sides of the shape, I must be having this side, this semicircular side or something. And then this thing, we know a side of a circle is the circumference, I get. And then the circumference is known by 2 pi r. 2 pi r, I get. But now we're not having a full circle, we're having a half circle. So we're going to divide by half or divide by 2. Yeah, divide by using half. So if we divide by 2, we're going to have pi r as our circumference. I get? Yes, pi r.
Yeah.
Now we substitute r is x. So we're going to be having pi x. Pi x.
So this is the
Yes.
circumference.
Yeah,
part
that is the
here.
circumference, the highlighted part in here. I get?
Okay, just a reminder, how do you get the circumference if you've forgotten? So we have the area. Ne? The area of a circle is given as it's pi r squared. Ne?
Yes.
If you want to get then the circumference is the derivative of the area, ne? Is the rate of change of the area. So we'll say that the circumference is going to be given by differentiating in terms of r. You're going to have 2 pi r. If you're going to differentiate in terms of r, that's how you get the circumference.
Yes.
Now, unfortunately, they are not going. These are some of the things that we have to know. Like no one is going to tell us about these things, so we just have to know them. Okay.
Okay.
So this is the circumference chart.
Yes.
Yeah.
Oh, now, if we
Yeah. If we
yes, if we go back to the diagram, ladies and gentlemen.
yeah.
Okay, if we go back to the diagram, ladies and gentlemen, they say that this diagram, I get what I done with the semicircular part. I get now we're coming to the rectangle shape made up of 4 smaller rectangles. I get now the perimeter of this smaller, this bigger